Okay, today we're going to begin on Chapter 7, which is all about energy. It is important to note that the total energy of an isolated system does not change. Also keep in mind that energy is one of the most fundamental and far-reaching concepts in physics. It took nearly 300 years to fully develop the idea of energy and energy conservation. It's an abstract idea because it's basically a mathematical principle. So we're going to start off with energy of motion, and that energy of motion is called kinetic energy. Kinetic energy depends upon mass and the motion of the object, just like momentum did, but it is a little different. If you notice the formula for kinetic energy, we use a KE to represent kinetic energy, and it is 1/2 mass times velocity squared, or speed squared. So the kinetic energy is going to increase with the square of its speed. Now, with that being said, we have kinetic energy equals 1/2 mv squared. Now notice kinetic energy is directly proportional to mass. It is also directly proportional to the square of the speed. So in this question, they're asking us what happens to the kinetic energy of an object if its mass is doubled while its speed remains the same. Well, because it's directly proportional, the kinetic energy would also double. Now, kinetic energy, or any type of energy, has different units than you're used to, and those units are what we call a joule. A joule is a kilogram meters squared per second squared. Kinetic energy is not a vector quantity. If you remember, momentum was. So an object's going to have the same kinetic energy regardless of its direction as long as the speed doesn't change. Okay, let's do some problems. So in this one, the kinetic energy you're asked to find, so we're going to make our list, of a 70 kilogram person, so our mass is 70 kilograms, running at a speed of 8 meters per second. We're not going to use 154 pounds because then we would have to convert. We wouldn't get our units of joules. So kinetic energy is 1/2 mv squared. So we have 1/2 times 70 kilograms times 8 meters per second squared. So our kinetic energy is going to equal 2,240 joules. Okay, let's look at another one. So we have a car that's moving at 100 kilometers per hour. So our speed is 100 kilometers per hour. We're given the mass of the car to be 950 kilograms, and you're asked for kinetic energy. Well, in order to have a joule, we're going to have to convert this to meters per second. So we know that in 1,000 meters, we have 1 kilogram. In 1 hour, we have 60 minutes. And in 1 minute, we have 60 seconds. So that comes out to be 27.8 meters per second. So now we can determine the kinetic energy. 1/2 times the mass, which is 950 kilograms, times the speed, 27.8 meters per second, and that's all squared. Because if you remember, kinetic energy is 1/2 mv squared. So our kinetic energy would equal 3.67 times 10 to the 5th joules. Okay, let's try another one. So in this one, we have a 0.145 kilogram baseball. So the mass is 0.145 kilograms. It's thrown with a speed of 25 meters per second, and you're asked to find the kinetic energy. So here again, kinetic energy equals 1/2 mv squared. So we have 1/2 times our mass is 0.145 kilograms times v is 25 meters per second, and that is squared. So our kinetic energy will be 45 joules. Okay, and then on this problem, we're asked at what speed does a 1,000 kilogram compact car, so we're looking for the speed of our car. We know the mass of our car is 1,000 kilograms, have the same kinetic energy as a mass of our truck is 20,000 kilograms, and our speed of our truck is 25 kilometers per hour. So here again, we have to convert kilometers to meters per second. So we have 1,000 meters, 1 kilometer. We have in 1 hour, we have 60 minutes. And in 1 minute, we have 60 seconds. So that's going to give us 6.94 meters per second. Okay. So we want to know same kinetic energy. So that tells us we have to find out the kinetic energy of both the car and the truck. Well, we have the kinetic energy, remember, equals 1/2 mv squared. So kinetic energy of the car is going to be 1/2 times 1,000 kilograms times v of the car all squared. So that is going to be 500 kilograms times speed of the car squared. Now the kinetic energy of our truck is going to be 1/2 times the mass of our truck, which is 20,000 kilograms, times our speed of our truck, which is 6.94 meters per second, all squared. So our kinetic energy of our truck comes to be 4.8 times 10 to the 5th joules. Now we want to know the speed when they have the same kinetic energy. So we want to set the kinetic energies equal. So we're going to have the kinetic energy of our car equal to the kinetic energy of our truck. Okay. We're going to divide both sides by 500 kilograms. That's going to go. So then we're going to have velocity of the car squared is going to be 4.8 times 10 to the 5th joules over 500 kilograms. We take the square root of both sides, and therefore we're going to get VC of the car to be 31 meters per second. So that is your answer. And that ends part 1 of chapter 7.